We're going to complete SolidWorks Simulation Chapter 7, which is thermal analysis. We're going to use a matrix unit, and the settings will be like this. So this is the model you can download from the FOL, and here's the thermal analysis, giving the temperature on all these surfaces as shown in the handout. Okay, 400 Celsius degree, 800 Celsius degree, and 100 Celsius degree, and 250 Celsius degree on each surfaces. Then we're going to see, after the analysis, you can see the heat flux, the temperature distribution, and heat flux in vector format. After that, then we will conduct a simulation, static, and there's a stress distribution, displacement distribution, and also strain distribution. Okay, we're going to get started. Let's look at let's open the file first. So here's the file. Hit OK. Let me save this one first. Save as. So underscore LSX. Hit OK. Just delete this one. Delete this one. So here is the 3D model, and the material is already applied on it. So let's look at here. The material brass is being selected. You don't need to worry about, otherwise you need to define the material itself. Now let's start with the simulation, the new simulation, new study. We're going to, by default, is a static analysis being given, right? So, but in this time, we're going to use the thermal. Okay, and then say we're going to give the name as in here. So the name will be crossing pipes. The name will be crossing pipe. It's a thermal, and let me put this one aside. Okay. Now we get a new simulation. Okay, get a simulation. Let's save this file for now. And then what we're going to do, we're going to look at the thermal property. In this option, we're going to you can either choose transit analyze or use a static state. We're interested in the static state, so we're going to choose this one. Uncheck automatic solvers selection. Okay, so we are interested in we're interested in FEA. Okay, so flag the result folder. I'm going to put this one in here. Hit OK. Then we're going to define the temperatures. So from the picture, we know the temperature. So thermal load, temperature, select the phase, and Celsius degree. This is 400. 400. Hit apply. All right. Then add another one, temperature, which is 80 degree. 80 degree. Accept. Then temperature on this side is going to be Celsius degree 100. Okay. And then the bottom temperature at the bottom is Celsius degree 250. Hit OK. Now you can see in this phase is 400 Celsius degree on top, 8 Celsius degree, and the back is 100 Celsius degree, and the bottom 250 Celsius degree. Once we have this, then let's save the file. Okay. Now let's create the mesh. Create a mesh. According to the instruction, we're going to use the find craft. Okay, and then advanced. So we're going to mesh parameter. We're going to use curvature based mesh, and this millimeter, and this one. Okay, the maximum element size will be 5 millimeter, and then the minimum element size will be, it's being automatically given, provided, and here minimum number of elements in the circle 16, and element size growth ratio 1.5. Okay, accept the mesh, and it will generate it by the system. Okay, save your file. Now we're ready to solve the problem now. So run this study. Now you can see the temperature distribution is being plotted here. Okay, so let's look at it. So you can see there's a temperature, right? Chart option. Okay, so and the color option here. Okay, now this temperature Celsius degree, but this is given in Kelvin, right? So what we can do here, we would like to change this one to definition temperature Celsius degree, and look at the color definition. So we're going to use 12 in this case, and by default is 5. Hit OK. Now you can see here's the 400, right? 400 and so on. Let's save the result. Then what we can do, we can add a new plot. This time we're going to look at heat flux and property. And we're going to accept the default settings so far. Hit OK. Now you can see the heat flux is being distributed here. Okay, the largest heat flux is here. Okay, we can also create a define thermal plot. Heat flux again, heat flux, and then chart option. This time we're going to vectors, right? So definition, show vector plot, show as a vector plot. Then once you choose this, then go back to here, vector option. We're going to have hit OK first. Takes a while, right? So then let's edit so vector plot, oops, position color, vector plot option. Then we're going to give 900, and we're going to give the distance 10%, and use single color, and we're going to choose black. Hit OK, and hit OK. Now you can see we have the heat flux, right? So showing where the heat being flow in this temperature distribution. Hit OK. Save your file. Okay. You can also hide those temperature. Save again. Now we are interested in the stress distribution due to the temperature difference on this single part. Then what we can do, we're going to create a new study, but the new study will be static, right? So static 1, okay, stress, hit OK. Let's see. Okay, let's hit OK. Save your file. Now you can see stress study is being given. Let's go to property, and then we're going to use soft spring to stabilize model, right? So, and we also want to load the thermal effects. So we're going to say temperature from the thermal study, right? Cross pipe. All right, and here I would like to use Celsius degree instead of the Kelvin, and that's it. Let's hit OK, and then save the file. So we already have all the settings, right? There's no other load, so it's a external load is the thermal. It's being added here. It's being added here. Then we need to create our mesh. Create a mesh. Ideally, if we can create a mesh similar to what we have in the crossing pipe thermal analysis, that would be great. However, we'll not be able to do so, right? So what we're going to do, we're going to use the same size here, and then accept all the default settings. Okay. You can also choose curvature-based mesh. Okay, you can also choose curvature-based mesh here. So 5. Okay, and then 16. 1.5. Right. And then hit OK. The mesh is being created. All right. Then you can solve the problem. Once you solve the problem, then the stress is being given, a displacement is being plotted, and the strain is being plotted. We are interested in the strain, right? Which is deformation. Okay, and then we look at the stress. Then the stress is being given, distributed here. Let's save your file. If you wish, you can also use the previous study to plot your results. And if you zoom in, you can see the results being given. You can also show the settings, model, okay. Oops. Continuous model, boundary condition. You can see mesh, right? So then the mesh is included in your results. Okay, this is a demonstration of the first part of chapter 7, and then you're going to do the rest, use a similar method to complete this assignment by yourself. Once you're done, save your file and close your part.